Welcome back, boys and girls, to Grade 4, Lesson 5.5. Prime and Composite Numbers is our lesson title. Our essential question tonight is, how can you tell if a number is a prime or a composite number? So let's get right into it because we have a little bit of work to do today. A prime number is a whole number greater than 1 that has exactly two factors, itself and 1. So we know a lot about factors and we've learned a lot about multiples, so we want to make sure that we keep our definitions straight. Let's take a look at the definition for a composite number. A composite number is a whole number greater than 1 that has more than two factors. So we'll get into this right now and take a look at some examples of prime and composite numbers and how we can figure those out. But I think you might have a pretty good idea. Let's take a look. Let's determine the factors of two different numbers. So the factors of 12, let's see if we can list them from greatest to least. Thinking using mental math, what would be the factor pairs of 12? Now, thinking of those factor pairs, let's put those factors in order from least to greatest. Well, the first factor pair is 1 times 12, and I know that 12 is even, so it's divisible by 2, so it's 2 times 6. And I know that 12 is also divisible by 3 because 1 plus 2 of 12, of the number 12, equals 3. And 3 divided by 3 is 1. So I know that 1, 2, and 3 are factors of 12, as well as 4, 6, and 12. Now 13. 13 is an interesting number. When we created our arrays in class and we hung them on the wall, what did we notice? Well, we noticed only one array for 13, which means that we could only create one rectangular array. Sorry about that, I had to sneeze. So our factors of 13 are 1 and 13. I can't think of any other whole numbers that I can multiply together that will give me the product of 13. So the factors of 13 are 1 and 13. Since 12 has 1, 2, 3, 4, 5, 6 factors, I would say 12 is composite because 13 only has the factors of 1 and 13. I can say 13 is a prime number. So I have 12 is a composite number based on the number of factors, more than 2, and 13 is a prime number. Let's continue. I know that we're pretty good with the numbers of 1 through 25 because we created those arrays in class and then we figured out the factor pairs. So I'm pretty sure that you've got a handle on what are the prime numbers and what are the composite numbers of 1 through 25. Let's look at some larger numbers. We're going to think about that divisibility rules. What are the numbers? What are the factors of 34? Well, the first thing I do is say, let's try and find those factor pairs. I know that 1 times 34 is 34. Those are two factors of 34. 34 is an even number, so some number times 2 must give the product of 34. Well, you're right, 17. I know that looking at the divisibility rules, 3 plus 4 is 7, and 7 is not divisible by 3, so 34 is not divisible by 3, so 3 is not a factor of 34. 4 is not a factor of 34. I can't think of any whole number times 4 that would give me 34. I know that 34 is not divisible by 5 because it does not end in 0 or 5. It's not divisible by 10 because it doesn't have a 0 in the ones place. I know that 34 is not a multiple of 9. It's not a multiple of 8. I'm pretty sure I've just found all of the factors of 34. So the factors of 34 would be 1, 2, 17, and 34. And because 34 has more than two factors, 34 is a composite number. All right, let's continue. Whoops, that's kind of a mess. Let's continue. How How about 45? Let's see if we can come up with the factor pairs of 45. We certainly know that 1 times 45 equals 45. 45 is not an even number, so I know that it's not going to be divisible by 2. 2, therefore, is not a factor of 45. But 4 plus 5 is 9, and 9 is divisible by 3. So I know that 3 times some number equals 45. Let's think. You're right. 3 times 15 is 45. Oh my goodness, I already have 4 factors. Can you think of any other numbers that you can multiply together to get the product of 45? How about 5 times 9? So let's take a look, boys and girls. We know for sure that 45 has a factor of 1, 3, 5, 9, 15, and 45. Therefore, I'm pretty sure you can say that 45 is, in fact, a composite number. Let's go ahead and write that down. 45 is a composite number. All right, let's continue to go. All right. Let's try the number 67. Okay, certainly I know that 1 times 67 is a factor pair of 67. Now, using what I know about the divisibility rules, is 67 an even number? No, it is not. So we know that 2 cannot possibly be a factor. If I add 6 plus 7, 6 plus 7 is 13. 13 is, 13 is not divisible by 3. Therefore, 3 is not a factor of 67. Okay? Let's start again. So far I've only found one factor pair of 67, 1 times 67. I know that 67 is not divisible by 3 because 6 plus 7 does not equal a number that is divisible by 3. I know that 67 is not divisible by 4. It's not divisible by 5. It's certainly not divisible by 6, by 7, by 8. You know what? I think we found all the factor pairs of 67. So the factor pairs of 67, or the factors of 67, are 1 and 67. Since 67 only has 2 factors, I know that 67 is a prime number. Now, boys and girls, I'm going to give you a couple of numbers, and I want you to determine whether or not these numbers are prime or composite. I want you to use what you know about factors, factor pairs, and multiples, and I want you to bring into play the divisibility rules chart that we have created in our classrooms and that we've worked with. Let's try these following numbers. Here are 3 practice problems that I want you to do tonight for homework. I'd like you to tell me whether 28 is a prime or a composite number. I want you to show the work on how you know. I want you to provide the factor pairs. I want you to write your factors in order from least to greatest. And if you use the divisibility rules, I want you to tell me which apply. 28, 73, 69. Okay, boys and girls, by the end of this activity, you should be able to answer the question, how can you tell whether a number is prime or composite? All right, good night.